Hello, this section is about solving inequalities. It uses a lot of the skills that we've picked up for solving equalities, and then it adds just really one or concept. And we have a couple of different methods to do, so you can see just over here, there's not a great deal of slides. We've solved all kinds of equations. When we work with inequalities, you start off by solving the related equation. So the related equation is just what you would have if you replace that greater than or less than with an equals. And we have two methods for dealing with this. We can deal with it algebraically using some test things, and we've also got graphical solutions, and they both have advantages and disadvantages. On this one, I've got the steps here very specifically listed out, and then we'll have another example where we don't, but we're going to solve the related equation first. To solve the related equation, we will first of all just take this x squared minus 4x minus 5 and pretend that it says equals 0. So to solve something like this, one of the methods we can use is factoring. If that didn't work, we could use the quadratic. But here, what multiplies to 5 and subtracts to give me negative 4? Well, that's going to be x minus 5 and x plus 1. Now, if I set each of these equal to 0, I will find that x is either positive 5 or negative 1, because those are the zeros for each one of those. Step 2, use the zeros of the related equation to form intervals of the x-axis. So it's not that it has to be a perfect x-axis, and we're not really worried about spacing. You just want to put these on there so that you have them from left to right. So somewhere on this axis there's a negative 1, and somewhere to the right of it there is a 5. Now what you can see is that actually cuts this x-axis up into 3 different sections. So we take a number in each of these sections that we test. So what I'm going to do up here is just write test, and I'm going to pick a number to the left of negative 1, in between negative 1 and 5, and then to the right of 5. And that's where we're going to test our values. It doesn't matter what you choose. So like in between here, I try to choose numbers that are easy to work with. So like my favorite ones to choose are 0 or 1. Or over here, I like to often choose negative 10 and positive 10 because they're easy for me to do mental math with. So these are just numbers I've picked that are in these sections of the x-axis. Now what we want to do is actually determine if we take those values and we plug them into our original inequality, we want to find out, is it greater than 0 or less than 0? And so I can do that with a sign by just figuring out, will it be positive or will it be negative? You can find out exactly what it equals if you want to use your calculator to do it, but I'm just going to take negative 10 and look at it in this factored form. If I put a negative 10 in here, this will be negative, and this one will be negative, and a negative times a negative is a positive. Now a positive is greater than 0. So this section works, which tells me this section up here is going to work. When I plug in a 0, I end up with my x's will disappear, and I have a negative times a positive, which is negative. But a negative is not greater than 0, so that section does not work and will not be part of my answer. If I plug in a positive 10, this first parenthesis is positive, the second one is positive. A positive times a positive is a positive. So this section works, which means this part of my x-axis is going to work. So that was step 3. Test a number from each interval into the original inequality to find the solution intervals. But then we need to determine whether or not the interval endpoints are open or closed. They are open when it's a strict inequality. This one is a strict inequality. It doesn't say or equal to, so those will be open. And then our solution from the x-axis, from left to right, is negative infinity to -1 unioned with 5 to infinity. Now, this says your calculator's table of values is great for testing, and it is, because for a lot of people, they would rather just type this into the y equals and then plug in their test numbers like that. So I'll probably do that one on this next example so you can see me use that table of values. So there's one example for you solved algebraically. So now we've got a couple more. We'll also solve these algebraically then. First of all, we look at the related equation. That's my related equation. Now I need to solve this. So I just do whatever steps I need to solve this. So like I'm going to bring the x over to the left, and then I'm also going to subtract 3, so that constant will move over to the left. So then I end up with x squared plus 2x minus 8 is equal to 0. What multiplies to 8 and subtracts to 2? Well, 4 and 2. So this one's going to factor. So I can have x plus 4 and x minus 2. So I have two zeros. I have one at -4 and one at 2. So in thinking of the x-axis, I know that somewhere on the x-axis there's a -4. Somewhere to the right there's a 2. Once again, I've broken this up into 3 sections. So now I want to pick a number to test. Now this is arbitrary, anything to the left of -4. So once again, I like -10. Anything between -4 and 2. So I like to do 0. I just like to do things that have easy math, that are easy to do math with. And then to the right of 2, I can pick a +10. Those are my go-to numbers, and sometimes I'll use a 1 if I can't use a 0. Our inequality would have been x squared plus 2x minus 8, oh, that certainly didn't look like an 8, is less than or equal to 0. So I'm going to use this one to plug those numbers into, and this time I'm just going to use my calculator so you can see me use that table of values. So you would go to y equals, and even though it says equals, I'm going to go put in my x squared plus 2x minus 8. And then I'm going to go to my table, because now I can just plug in my test numbers, -10, 0, and 10. And I see that I have a positive, and then a negative, and then a positive. So that means when I test it in this region, positive, and then negative, and then positive. Because I'm looking for things that are less than, it's this negative section that I'm interested in. And I need to determine open or closed, but this one says it can be equal to, so it will be closed there. So my solution for this problem is the interval -4 to -2. A word of caution. It is very, very common for every other section to work, but that is not a certainty. You must check every section, because if we had a double 0, then it's possible that you would get the same sign on both of them. There's some ways to tell otherwise, but for this point in your math learning, it's probably easiest just make a note, check all of them. Don't be surprised if it's every other one, but check all of them in case you get the same sign on both sides. One more of these, and I think we'll have the hang of this then. My related equation, x cubed minus x is equal to 0. I can factor this one, so I'll have x coming out of both, which leaves me x squared minus 1. X squared minus 1, though, factors into x plus 1, x minus 1, which means I have 3 zeros. 0, -1, and 1. So on the x-axis, line those up. Boy, I wish I could draw a straight line. That would just be such a fabulous feature. Maybe a superpower for me. -1, 0, and 1. So I actually have 1, 2, 3, 4 sections I need to test. So we need to pick some test numbers. I'm going to pick -10, -1/2, because, you know, what's my other option? Really, I got to pick something in that region. 1/2 and 10. So y equals, and let me move this over so that you can see that we have x cubed minus x. And then we're going to go to our table. -10 is already in there. And then I needed -1/2. Now you could put the decimal, or you can just hit the division. So -1/2, 1/2, and +10. So again, what I see is that it went negative, positive, negative, positive. So I'll bring that back over. Negative, positive, negative, positive. Now, which sections was I looking for? I wanted greater than 0, which means this 2 sections that are positive are my solutions. Now you look at, should it be open or closed? That goes back to the original. Since this does not have a line under it, then that's a strict inequality. And strict inequalities are open, while these that say or equal to are the ones that are closed. So this is going to be open here and open there. So my answer is -1 to 0 unioned with 1 to infinity. So when we solve graphically, we are going to graph the related equation. And then we will use the zeros of the related equation to form intervals of the x-axis. And then we will look, this says inspect, that just means look at the graph to figure out which ones are solutions. Now, how will you do that? If it's supposed to be greater than 0, any section that is above the axis is a solution. And then we determine if it's open or closed in the exact same way. So here, what I want to do is I want to graph y equals, clear. I have x cubed plus 3x squared minus x minus 3. When I hit graph, it might not be on the correct window. I may have to adjust my window, but let's look at it and see. Here's the thing. What are we looking for? We're looking for where it's greater than or equal to 0. So in terms of the graph, I'm looking at this section and this section. So this definitely appears to be a -3 and a -1. So between -3 and 1, and then from 1 to infinity. If I'm not certain that that's a -3 and a 1, I could tell it to find the 0. So I just want to show you how to do that again in case you weren't absolutely certain what you were looking at. We can hit second, calculate, tell it to calculate a 0, so that's option 2. It's going to give us the left bound and then the right bound and then a guess. So I need to use this left arrow key to get to the left of my x-intercept that I'm looking for. It doesn't matter if you're above or below, you just have to be to the left. That really tells my calculator, start looking here. Then I need to give it a right bound, so I go a little to the right. So really what I've told it is 2 numbers and that it's between. I know the 0 is between those 2 numbers. You could do the guess, but you don't really have to. It doesn't really save it time. So now I can see that the 0 is at -3. That's how to find a 0 on your calculator. Now I do happen to know on this one, it is -3, that's a -1, and that's a 1. So it is going to be, the solution that you're looking for is the part that is greater than 0. So I'm looking for this area because that's above the x-axis, and this area, that's above the x-axis. My solution goes from, and this one should be closed. Now why should it be closed? because when I look right here, it says or equal to. So closed from -3 to -1, unioned with +1 to infinity. Down here you see the note, calculators may find the zeros through an app or the calculate feature. They're really great when it's on a whole number like that, or if you have instructions that say round to 2 decimal places. But if you have to have an exact zero and it's something like the square root of 2, your calculator's not going to display the square root of 2. It's going to show you that in decimal form. So occasionally, you might have to say, well, I'm going to have to go solve this by hand and factor this. And this would have factored by grouping. But so this is how to use the graph. Most people really like this way to do it. But again, it does have some limitations if you don't have nice, pretty little zeros. When we're dealing with rational inequalities, we actually have to deal with more than just the zeros. We have critical numbers, and critical numbers include the zeros like we were just doing, but they also include undefined values. So notice here, zeros come from wherever the numerator equals 0, and undefined values come from where the denominator equals 0. So we need to find all the places that either the numerator or the denominator equals 0, and that's where we cut up our axis. Then anything from the denominator will always create an open interval because it's undefined, it can't be there. And for the numerator zeros, we go with whether or not it was strict or not strict. So let's look at this with rational inequalities then. You need to get zeros from the top and zeros from the bottom. Well, this one, I don't need to factor it. 0 is the 0 from the numerator. That's what would make this equal 0. The denominator would become 0 if x equals 4. So those are my critical numbers. So when you're thinking of your x-axis, oh look, it was a straight line. I don't know how that happened. 0 and 4. So I have 3 regions to check. Now I do know that up at the top from the numerator, I determine open and closed by this. So this one is going to be closed. But anything from the denominator will always be open. It's undefined there. This one could be open or closed, but it's closed because of that or equal to. So now it's the same sort of situation we were in before. We want to pick some numbers to test and find out what's going on. So if I do, maybe I'll do -1, 1, and then 10. You're just picking numbers. And what I typically do myself, you could use your calculator, but I generally just look at this and think of what the signs will be and what the overall value would be. So if I plug a negative in to the top, I get a negative. If I plug a negative into the bottom, I get a negative. And a negative over a negative is a positive, which is in fact greater than or equal to 0, so that works. So I know I want this section. If I plug in a +1, I get a positive over a negative, which is a negative, so that section doesn't work. I plug in a 10, I'll get a positive over a positive, which is positive, which does work. And again, about open and close, because 4 came from the denominator, it has to be open there. 0 came from the numerator, so I look at the symbol, it says or equals to, which means it's closed. So my solution here is -infinity to 0, closed at 0, unioned with 4 to infinity, open on both of them. This is a lot easier than what we did in the last section, isn't it? You needed a break. All right, so one more of these, just some practice. Now, you might be asking yourself, could these get a lot more difficult? Yes, they could, but they really don't in your homework. So I decided not to do examples a lot more difficult than what you were having to do. The 0 from the numerator is 0. Because it's from the numerator, you look here to see if it's open or closed. Since that is a strict inequality, that one will be open. The 0 from the denominator is -6. Zeros from the denominator are always open. So our critical numbers are 0 and -6. That made up for it, didn't it? So now I have 3 regions to test. Maybe -10, -1, and 1. Okay, because you're just picking numbers there. If I plug in a -10, the numerator is negative, the denominator is negative, so the entire thing becomes positive. But I'm wanting less than 0, so that one does not work. If I plug in a -1, the numerator is negative, the denominator is positive, so the entire thing is negative, which is what I want. Okay, so we're looking at this region. And again, the next one's probably not going to work, but we're going to check. So 1, if I plug in a 1, I get a positive over a positive, which is positive. That's not what I'm looking for this time. So I know at 0, it was open, and at -6, it was open. So my solution is -6 to 0, both parts open. All right, and can you believe it? That finishes up this lesson. Don't forget to get in touch with me. Use Ask the Instructor if you need some help. I am happy to work with you.